So by this time we have converted sulfide, carbonate and hydroxide ores into oxide. That is, part A is done of the isolation of metal. Now we are converting oxide into metal using different techniques. So the first technique that I am using to convert metal oxide into metal is smelting, also known as carbon reduction. In this method, we are going to heat the oxide along with carbon and reduce it to metal. So bhaiya, the heating is done. That means it's a pyrometallurgy technique. Heating based technique of extraction of metal is pyrometallurgical technique. So we use smelting for tin, lead, zinc and iron. These are the elements. I will tell you a short trick at the last to remember different examples as if which is the exact metal will be extracted from the oxide using which method. I will tell you a trick compiling at the last. But firstly, let us do method by method, step by step. Before elaborating this, I will first elaborate gangue and flux reaction. So we understand gangue is the impurity present in the ore. Flux is the impurity that you add to remove gangue, and they together react to form slag. This reaction is acid-base reaction. Example, for iron metallurgy, silica is the impurity. SiO2 is the impurity for iron oxides. So here silica is gangue and silica we know is acidic in nature. So the flux you will add will be basic in nature, that is a metal oxide. So we add limestone. Limestone on heating gives calcium oxide. Whenever in chemistry you need calcium oxide, you will never directly add calcium oxide. You will add CaCO3, you will heat it up, you will get calcium oxide easily. Apart from that, one more example we can take of copper metallurgy. For copper metallurgy also, the gangue is FeO. FeO is the gangue. The impurity for copper ore is FeO or FeS sometimes. FeS get converted to FeO. So finally we have FeO that we have to remove. That is the gangue for us. That is a basic oxide because metal oxides are basic in nature. So the flux should be acidic and the flux we have is SiO2. SiO2 is found around us on the earth crust in ample amount, that is sand or clay you can take, that is silica, that is acidic in nature. They will react with each other to form slag, which is FeSiO3. Similarly here also, gangue and flux will react, acid-base reaction to form CaSiO3 as slag. So flux are added just opposite to the medium of the gangue. So if gangue is acidic, flux has to be basic and vice versa. Talking about the smelting, the example I'll be taking first will be FeO. FeO is heated in the presence of coke. Carbon takes the oxygen away, making this thing. So we got the metal iron extracted out. Also, this CO which came out can also act as a reducing agent and can easily reduce FeO into FeNA. So basically, even though you are starting by adding coke for the reduction, but during the process carbon monoxide is also produced, which also act like a reducing agent. So how many reducing agents you have here? We have carbon. Initially we added carbon only. We call it carbon reduction because we are starting using carbon, but then some of the carbon get converted to CO and both are reducing agents. Here mostly you will see carbon monoxide is written for most of the reactions as reducing agent. Do not wonder why, because a very simple logic you will understand. As I told you, in the calcination and roasting process, the final oxide you are going to get is going to be porous in nature. So bhaiya, what happens? Carbon coke is a solid. So FeO is a solid, carbon monoxide is a solid, so only their surface can react. They cannot mix with each other. So their surface react. As soon as their surface will react, carbon monoxide is produced. Now carbon monoxide is a gas. This gas, carbon monoxide, which is produced by reaction of coke with iron oxide, will go inside the pores of the remaining FeO. Because you remember in calcination roasting, both cases, whichever oxide you got is porous in nature. So the carbon monoxide produced will enter inside the pores and will do the home delivery of reduction. Okay, bhai sahab? So even though you started using carbon, most of the reduction is done by carbon monoxide only. Why? Because carbon reacts only with the surface where it came in contact. Whereas carbon monoxide being a gas, it can move anywhere, will go inside the pore and will reduce everyone inside the whole oxide, porous oxide also. As a result, carbon monoxide is the major reducing agent in the case of smelting. So you will see a lot of reactions of CO rather than carbon. One more example I will give you. Here itself I will cover up zinc extraction method. For zinc extraction, I will take the ore ZnO. ZnO react with carbon at 1673 Kelvin and we get zinc plus carbon monoxide. That's how we can extract the zinc from ZnO ore. Table 6.1 again you can check. You will find this ore there. One more thing. How this process is carried out, you make small briquettes. BRICKETT briquettes. Very small size bricks are called briquettes. They are made up of ZnO plus coke plus clay and then they are heated. So this reaction carries out. Clay there is used like clay is SiO2 there, used as a flux only. That's not much important to discuss here for the NEET syllabus. All you have to remember is that zinc oxide is there. So you are very well acquainted of this fact. If you have metal oxide, it has to be reduced to metal. One of the major process we use is smelting, that is carbon reduction. In fact, I can give you one more example and the concept will become very strong if you understand the example very well. The other example I can give here is of copper sulfide, that is copper glance also. So Cu2s plus O2, we can also use this method here. It became Cu2O plus SO2. This is what you did as roasting. After roasting, when you got copper oxide ore, instead of tin, lead, zinc, iron, can I use copper oxide also with carbon? Let us check. So here copper oxide with carbon will form copper plus Cu. Is this reaction possible? 100% possible. So how can you say so? Simple. Tin, lead, zinc, iron, all are more reactive than copper. All are more reactive than copper as per the reactivity series or electrochemical series. If these oxide can be reduced by carbon, obviously copper oxide can also be reduced. Then what happens? This is how you can get the final copper extracted. But this is not commercially most viable option. This logic I want you to understand right now. That's why I'm giving this example. कि भैया copper oxide can be reduced by carbon also, but we don't reduce using carbon. Why? Because there is another technique of reduction of copper, copper sulfide into copper. Another technique of reduction is there, which is even cheaper than this technique. Money is the main driving force here. So there can be thousands of chemically feasible methods of getting copper from copper ore, but we will choose that method which is the cheapest one. And this is possible, but this is not the commonly used method for the extraction of copper. We use another method which is known as self-reduction. We'll discuss in the later phase. Smelting I think is clear, pyrometallurgy part. Now we will take the example of iron metallurgy, that is the major metallurgy that we are going to discuss here. Extremely important. So hang on and check. I'll just change the image magically.